So again, talking about those organisms that are responsible for nature's dirtiest jobs, right? Cleaning up the dead and decomposing stuff that's in our environment. We're gonna review their role in our ecosystem and why they're important. We're gonna take a look at some local examples here in Arlington, and then we're gonna talk about ways that we can support or help them in our daily life, okay? So moving right along here. Before we jump into specific decomposers and scavengers, I did want us to sort of understand their role in the larger ecosystem. And so we're going to start to do that by looking at a food chain, right? A food chain is one way that we can understand the relationships between organisms in an ecosystem, and really it helps us understand the movement of energy in an ecosystem. So down here in the middle, right, you've got a really basic food chain that you might find in our area, right? All energy on Earth starts from solar energy from the sun, and then our lovely producers, the grasses and the trees and the shrubs, all of our plants, convert that solar energy into chemical energy through photosynthesis and make that energy available for all of the rest of the creatures on the planet, right? So we've got our grasshopper here that might nibble on that grass. That solar energy that our grass converted into chemical energy is now available for the grasshopper to eat. The grasshopper is going to eat it. Our shrew might eat that grasshopper, so that energy moves from the grasshopper to the shrew. And then we've got our owl here, really our great horned owl, like you see in this picture, are considered top predators. So at the very top of our food chain, there isn't anything that eats them, right? They're going to eat other creatures. It's going to eat that shrew and gain that energy from the shrew. When we think about energy moving through an ecosystem, we can think of it as a one-way street, right? That energy moves from the sun to the grass, to the grasshopper, to the shrew, to the owl, and it doesn't ever make its way backwards, right? And there is actually less energy available at every step along the way, which is why we don't have as many top predators like owls as we do grasshoppers. Right? There's just not as much energy available for these larger animals once we get 2 or 3 or 4 steps away from our producers. Okay? Food chains can be a little limiting because obviously we know it's more complicated than this, right? There might be other things that eat the shrew. There may be other things that eat the grasshopper. The grasshopper might be eating more than just grass, right? And what happens to all of these creatures after they've died? Right, so our food chain doesn't really give us all of that information. Instead, we need to look at a food web. So you can think of a food web as lots of different food chains that are intersecting and interacting. A food web really, again, is helping us to understand the relationships between organisms in an ecosystem and understanding how that energy moves through the ecosystem. But our food chain, or our food web, right, allows us to see a bigger picture. Not only does our food web allow us to understand the movement of energy through a system, but it also allows us to understand how nutrients might be moving through that system. And that's because the food web also includes our scavengers, our decomposers, and our detritivores, right? Our 3 types of organisms that are responsible for dealing with the dead stuff, okay? These organisms, right, may all work simultaneously on a dead item, whether it's a leaf that's fallen from a tree, or a stump, or a rabbit that's been hit by a car. And they are going to obtain their energy from that dead stuff. So in some ways, you can think of decomposers, detritivores, and scavengers as the place where energy's journey ends, unless there's another animal that eats them, which happens sometimes. But they are sort of this link for the nutrients that are cycling throughout our web. So without our decomposers, scavengers, and detritivores, right, there's a missing link, okay? The nutrients, right, that were in our producer, our grass, right, are gonna make their way into the body of the grasshopper along with energy. And then that grasshopper is gonna get eaten by the shrew, and that shrew is gonna obtain its nutrients and its energy from the grasshopper. Our owl or our red-tailed hawk in this example is going to obtain energy and nutrients from the shrew. But when that hawk dies, right, something has to be able to break that hawk's body down to put those nutrients back into the soil where they can then become available for new producers, right? So without scavengers, without detritivores, without decomposers, those nutrients don't cycle through the system, right? There's a limited amount of nutrients. That amount doesn't change. It has to cycle through the system. So I hope that makes sense, right? Without scavengers, decomposers, and detritivores, right, what would happen? So you can imagine a world without organisms that take care of the dead stuff for us. It would pile up all around us, right? We'd be walking up to our shoulders in dead leaves and logs and branches and all kinds of yucky dead organisms that wouldn't have been broken down. Really, though, what I want us to understand is that without scavengers, decomposers, and detritivores, those nutrients that we talked about wouldn't cycle through that food web, right? There would be no carbon, no nitrogen, no phosphorus available in the soil for our producers like trees and grass, right, to utilize. Our decomposers, our scavengers, and our detritivores take those nutrients that are in that dead stuff and put it back into the soil so it can be made available for our producers, our plants. Okay, so this web or this cycle of life really wouldn't function without these creatures that a lot of times are often maligned, right? Because they eat the yucky stuff and we don't like to think about the yucky stuff. But we need these organisms, we need these creatures. Without them, it doesn't work. Okay, hope I've convinced you that these creatures are important. What I want to do now is sort of break down the differences between the three. So we've got scavengers, we've got detritivores, we've got decomposers. You will often hear those words used interchangeably, but there are differences between the three. So we're going to break down what those differences are, and also I'll share some local examples with you. We'll start with our scavengers. Okay? Scavengers are organisms that consume dead organisms to obtain energy and nutrients. Okay, they are often the first on the scene in the process of decomposition, and they facilitate food for detritivores and decomposers, right? A lot of times they make that food available for these other organisms. Okay, so when you think about a dead organism, a scavenger is going to be the organism that's first on the scene to kind of get the most out of that dead animal. And local examples include what we refer to as obligate scavengers, so animals that really just scavenge for their food, right? That's all they do. They only obtain their energy and nutrients from other dead things. And in our case, right, two really great examples in our area are our turkey vultures and our black vultures. We also have scavengers that might scavenge some of the time, right? Other times they might be herbivores, so they're eating plants, or predators, carnivores that are eating and hunting living animals, or a mix of the two, right? Our omnivores, but are sometimes also scavengers, right? Like wouldn't turn down a meal if it's already dead. So those are animals like foxes, coyotes, crows, bald eagles, raccoons, blue crabs. We can think of a lot of examples like this. Opossums, right? There's a lot of creatures out there that will sometimes scavenge if they need to. Our turkey vultures, again, are obligate scavengers, as well as our black vultures. They're only going to eat dead stuff most of the time. And because of that, they've got some really interesting adaptations in their body. So you may know already that vultures have really intense stomach acids that can break down some of this nasty stuff. And they also, in their guts, have some really bacteria that would be really harmful to us. So species like Clostridia and Fusobacteria that would make us really sick tend to occupy the guts of turkey vultures and black vultures, and researchers believe that that bacteria, really that intense, harmful to us bacteria, occupies the guts of these vultures because it sort of outcompetes other bacteria that might be harmful to the vulture, right? So by allowing this bacteria to sort of grow in their guts, right, as much as a vulture can allow that kind of thing, right, it sort of pushes all the other bacteria out. Okay, it's kind of amazing, right? Bacteria that would make us really sick doesn't make a vulture sick, but does sort of take up that space so that there's not room for other bacteria that might make a vulture sick as it's eating the sort of dead, decomposing, yucky, rotting other animals. Some other local examples of scavengers I've included here, right? I'll start with our bald eagle. We often think of bald eagles as being very majestic hunters. They are our nation's symbol, so we don't often like to think of them as scavengers. But of all of our big bad raptors or big bad birds of prey in our area, excuse me, bald eagles definitely scavenge perhaps more than any other. The half of our nation's bald eagle population lives in Alaska. And in Alaska, where there are pretty significant outposts for the fishing industry, right? You've got a large collection of dead fish. We find bald eagles have sort of become accustomed to that and scavenge almost exclusively, right? They're not going to hunt. They know that there are dead fish all around, and they can find those dead fish whenever they need a meal. So there are parts of Alaska where eagles really have become pests in some way, and this picture is taken from, I think, the Daily Telegraph in Anchorage. And you can see, here they are, hanging out in a dumpster. Not what we think of when we think of bald eagles around here, but they definitely are scavengers. I did include an aquatic scavenger here, again, sort of a classic symbol of our area, the blue crab. They hang out on the bottom of the Chesapeake Bay, and they are eating all kinds of dead stuff that makes its way down to the bottom there. You can see in this image, right, they're even eating other dead crabs. So they will engage in sort of cannibalistic behavior at times. And again, have no problem eating the dead stuff. Over here on the right, I didn't want to exclude insects. There are obviously plenty of insects that are decomposers, even some that we might not think of as scavengers. So we've got our eastern yellow jacket here. Predominantly feeds on nectar and pollen, but definitely at times needs protein, especially when they're feeding their young. So our eastern yellow jackets are a type of social wasp. They raise their babies in large groups with other wasps, and those babies, like all babies, right, need lots of protein to grow quickly. And so this is when they are going to be looking for other insects to eat, right, whether they're hunting those insects as predators or scavenging dead insects. This is also the reason you're going to find yellow jackets visiting backyard barbecues where they might be hanging out around hamburgers and hot dogs. They're looking for that protein almost always for their young. Their larvae really need that boost to grow big and strong. And then down here, I've included our American crow. We've got two types of crows in our area, the American crow and the fish crow. Both are omnivores, so they'll eat a mix of insects as well as berries and seeds, but they are also at times going to be scavengers. So in this image on the left here, this image was actually taken from a study done over in the UK in 2015. So these are corvids, not necessarily our American crows, but they are in the crow family. And these researchers were trying to figure out who visits, right, dead animals most often. Okay, so they put up stations. They put up 12 different stations with dead rats and observed the organisms that came to visit these dead rats to feed on them. They noted 17 different species, and of course crows were one of those 17. But what makes this sort of remarkable is that crows were the visitors 98% of the time. So over there in the UK, they had badgers visiting, they had foxes visiting, but really it was crows that were doing the bulk of the visiting, right? 98% of the visits to these dead rats were made by crows. So certainly their sort of role as scavengers has maybe been overlooked. There's more to learn and more to find out there. Give me 1 second, it looks like we have somebody who joined us here, so I want to make sure that they can get in. I'm going to stop sharing the screen for just a moment. Okay, make sure we're doing all right here. I'm going to come back to our presentation, so you should be able to see our scavengers again. We're going to move along here to our detritivores. So when we're thinking about that process of decomposition where dead stuff gets broken down, detritivores are the next ones in the journey. Like scavengers, they are organisms that consume dead organisms to obtain energy and nutrients. And like scavengers, they break down those dead organisms, whether it's plants or animals, internally by ingesting them, right? So they are eating the dead stuff, right? They begin or continue the process of decomposition. So sometimes they are the first ones on the scene. Sometimes they're there after a scavenger has ripped open a carcass. And they help with the fragmentation and mixing of detritus. So when we think of all that dead stuff in a forest that's fallen to the forest floor, they're mixing it around, they're making it, breaking it up into smaller pieces, and a lot of times they are consuming what we call macroscopic clumps of that dead stuff. So clumps that we can still see with our eyes, right? So they aren't breaking down the teeny tiny smallest stuff yet, but they are breaking down smaller stuff than our scavengers were, okay? This is where our definitions get a little tricky, right? Some people certainly would call a carrion beetle, which we're seeing here, a scavenger. Others would call it a detritivore because it is kind of focused on some of that smaller stuff. But there are certainly instances where a carrion beetle might be the first one on the scene of a dead animal before a vulture arrives. So it really just depends. I would consider them detritivores because, again, they're focused on some of the smaller stuff. Carrion beetles are a really cool example of a detritivore. It's the larva that actually eat the dead or decaying animal. The adults do care for the young, which is pretty unusual in the insect world. They are not social the same way our wasps are, but they do care for their young. And what they do is they lay their eggs in a dead or decomposing animal. The larva will eat the decomposing flesh of that animal. And the adults actually will eat some of the predators that might be preying on the larva. So they're going to also eat competitors as well. So they're going to be eating maybe maggots or other fly larvae that are present in the carcass, as well as some of those other adult predators that might be preying on the larva, really protecting their young as they grow inside this dead carcass. Local examples of detritivores include, right, worms, beetles, slugs, snails, crickets, millipedes, ants, termites, pillbugs. There are so many examples out there. These are sort of the creepy, crawly creatures that we think of when we think of decomposers. These are them. I did also want to mention that these guys are in the same family as another type of detritivore beetle called the burying beetle, which is actually an endangered species in the U.S. And burying beetles also care for their young, which is pretty amazing, and they actually feed their young the same way adult birds feed their babies, right? The adults are the ones who are gonna eat the dead stuff and actually regurgitate it for their larvae, which is just amazing. Burying beetles have had some success in terms of reintroduction and increased population. So there are tons of articles out there if you're interested in learning more about burying beetles. They actually will bury a carcass and feed their young from that carcass. And there's been some positive news about burying beetles, right? They are still considered an endangered species, but their population is on the rise in the US, which is cool. Okay. Some local examples of detritivores include our best beetle up there on the left, right? Our patent leather beetle. All kinds of earthworms, right? I've chosen our most common earthworm, the night crawler, here in the middle. Our giant millipedes, which are a favorite of mine. We'll share more about them in a minute. All kinds of snails, land snails as well as aquatic snails. We don't have any aquatic examples here. I've really stuck to the forest with these examples. Pavement ants, which are an invasive or non-native species of ant in our area, but are certainly detritivores as well as scavengers sometimes, as well as predators, right? They take the role of lots of different things depending on their circumstances, and then all different kinds of slugs. I've got a native example of a slug up here, the dusky Arion or Orion. I'm not sure how we pronounce that. And then on the bottom there is one of the largest slugs, terrestrial slugs in the world. That's our leopard slug, considered an invasive species in our area. So both our best beetles and our giant millipedes typically feed on dead wood. Best beetles in particular love the wood of oaks, hickories, and elms. And they're sort of unique in that they are detritivores who can really break down wood, which is pretty difficult for a lot of detritivores to do. They're going to prefer wood along with millipedes that has already got fungi and bacteria in it, which we'll talk about in a minute, that are really doing the work of breaking that wood down. So they've sort of got like a little bit of a bonus there if they choose a piece of wood that already has fungi or bacteria in it. Best beetles are also going to lay their eggs in wood, so they create these tunnels or channels inside dead or decaying wood, so they're sort of breaking up dead stuff that way as well. So in addition to eating it, they're kind of breaking it down just by crawling through it. Our millipedes aren't going to eat just wood, they'll also eat leaves that have fallen to the forest floor, lots of plant material, right? So these guys are feeding on dead or decaying plant material, and they are also what we call coprophages. So they will eat their poop, right? If there aren't enough nutrients the first go around, they're going to eat their poop, and those nutrients are going to get a second pass through their system. So pretty amazing. This little millipede is in its defensive posture, so when they feel threatened, they can curl up like that and sort of contain the soft parts of their body, protect the soft parts of their body. And they also can produce a toxin that can make them unpalatable, and if you are a human, right, that toxin can sort of burn or irritate your skin. I've never experienced that when I've held a millipede, but I'm sure there are folks out there with sort of more sensitive skin than I have. So in the middle here, we've got our earthworm. Our common earthworm or nightcrawler is considered an invasive species. We do have native worms in our area, so there are parts of the United States where worms are not native because the glaciers, when they came sort of to their furthest extent south, wiped out all of the earthworms that were here. And then as the glaciers retreated, right, there weren't really any earthworms that took their place until we brought earthworms from other places in the country. So if you go to somewhere like Maine or Vermont and you've got earthworms in the soil, those earthworms are considered an invasive species. There's all kinds of research out there, both on night crawlers as well as recently in the news, there's been a lot of talk about jumping worms, which have been here in our area for quite some time, but I think they're just sort of capturing everybody's attention again. And there's some research that shows that they are such effective detritivores that they're really like eating everything in our forests and not leaving much of a leaf litter or much of that humus layer left for any other species. So the research is out there. You're certainly welcome to explore on your own. And if you have questions about it, I can tell you a little more at the end here. Our snails and our slugs are going to feed primarily on decaying plant material, so dead leaves, dead wood, right? Same stuff as our best beetles and our millipedes. And like we talked about earlier, our ants, right, really eat anything. If you've got a compost pile at home and you open it up, chances are you've got ants of some kind hanging out in your compost pile. They are, I would say they can be considered scavengers. They can be considered detritivores, where they're really breaking down some of that smaller stuff. They also at times can be predators, where they're hunting for other insects. So it really just depends on the situation and the species of ant. Okay, nobody has any questions. We're going to move right along here. Next up are our true decomposers. So again, just like our scavengers and just like our detritivores, decomposers are organisms that break down dead organisms to obtain energy and nutrients. The difference here is that our decomposers absorb energy and nutrients. They don't ingest it. So our decomposers are bacteria, fungi, and protists. They're never going to eat or ingest, right, dead material. They're always absorbing it. And this process completes the process of decomposition, right? As they're absorbing what's left, right, it's gone after they're done, okay? They really metabolize detritus or dead stuff on a microscopic scale. So what's happening when they're breaking things down oftentimes is not something we can see with our eyes. But this sort of last step in the process is what really facilitates nutrients for plants and animals. So they are the ones who are truly putting the nutrients back into the soil for producers who can then be eaten by other organisms. Those nutrients become available for the rest of our web or the rest of our cycle all over again. Again, examples include our bacteria, our fungi like mushrooms and molds, and then some of our protists like our slime molds. Okay. All right, so here we have a great example of a lovely mushroom that's fairly common in our area. It's called chicken of the woods, and it is edible for humans, so it's pretty popular with those who are out and about foraging for mushrooms. It loves dead and decaying hardwoods. So again, oaks and hickories and maples. There are certain trees that chicken of the woods prefers to grow on, and I'm forgetting them right now, but if you're curious about it, I can look that up for you. I did want to talk more about bacteria and fungi since they are pretty interesting in their role as decomposers, right? I want you to understand that not all bacteria are decomposers. So lots of bacteria are out there that can be predators. There are bacteria out there that make us very sick, but then there are bacteria that are doing the good work of decomposing that dead material and putting those nutrients back into the soil. So soil bacteria are really tiny, right? Less than 4/1000th of an inch, but they make up the largest number and weight of any soil organism, right? So there are a lot of soil bacteria out there. This is amazing. Again, not all soil bacteria are decomposers, but a good number are, right? Most bacteria decomposers consume easy to digest carbon compounds and simple sugars, which means when we think about what they are decomposing, you often find bacteria on our dead animals, right? That's not to say that you aren't going to find bacteria in the forest helping to decompose leaf litter and logs and branches, but you are definitely going to find bacteria inside dead animals, right? Give me 1 second, right? I'm having, again, I'm at home this evening and I've got a dog who wants to go outside, so I'm going to be right back. Give me just 1 second. All right, thanks for your patience. Sorry about that. Get back to our bacteria here. Actinomycetes is a type of bacteria that can decompose many substances in the soil, but definitely specializes in those that are hard to decompose, like lignin and chitin. So lignin is what's in our branches, our logs, and our leaves, particularly our hardwoods. And so fungi often specializes in breaking down lignin. There aren't too many bacteria that do it, but Actinomycetes does do it. And then Streptomyces is another bacteria decomposer that we find in the soil that gives the soil its earthy smell. So if you've turned over the soil in the springtime while you're working in your garden or gone outside on a rainy day and you can smell the earth, right? That is Streptomyces that is giving it that smell. That is what you are smelling. Our fungi, right? I would say most fungi are decomposers. There are fungi out there that are not, but most are. And they also, like bacteria, typically break down carbon compounds. But fungi are sort of our specialists when it comes to breaking down lignin, which again is what's in plant matter, particularly our hardwoods. And so they are the primary decomposers in the forest as a result. There are fungi that break down keratin and chitin. And those are the fungi that are more likely to be present on dead animals or dead animal matter. And I will say that most fungi have a symbiotic relationship with plants, right? So fungi provide nutrients to the plants, and the plants provide sugars for the fungi. And there's tons of cool research out there about this network of fungi in forests that provides nutrients for the trees in the forest and helps the trees communicate to one another in times of stress. Right, when we look at a mushroom, we're seeing just the reproductive structure of that mushroom. The hyphae are like the network inside the fungi that convey sugars and convey nutrients, and that network is called, network of hyphae is called mycelium. And that network of mycelium is really what's responsible for sort of that conveyance all throughout the soil in the forest. So again, tons of cool research out there, really recent research on the ways that trees communicate to each other and how mycelium help them to do that. Super, super cool stuff. I would say that some of those fungi that are helping with that communication might be decomposers. Again, not all of them are, so it really just depends on the species. Some local examples of fungi as well as slime molds. We've got slime molds in here just because they're so crazy and cool. Up here on the top left, we have the amber jelly roll. Okay. Often found on hardwood, right, and really puffs up when it's very wet and really shrinks down quite a bit when it's dry out. Over on the right, we have turkey tail, which is a fairly common shelf fungus that you find on hardwoods as well. In the middle, we've got crumble cap. Okay, this is sometimes called fairy ink cap. It's another fairly common fungi in our area. On the left here, we've got the streaked bird's nest fungus. There are a number of bird's nest fungus that we have in our area. I think 3 or 4 different species, and they're really common in mulch. They really like to grow on that dead hardwood. So if you visit a playground anytime soon, definitely check out the mulch for bird's nest fungus. You can see why it's called that, right? The spores are inside these little capsules that look like eggs. And as the fungus sort of develops, right, that bird's nest opens and those capsules open and the spores are released, right? That's how fungi reproduces. These are 2 fairly common slime molds in our area. Again, slime molds used to be considered fungi. They are now considered protists. They are decomposers the way fungi are. They are absorbing nutrients and energy from whatever it is that they are living on, but they're different enough to be considered protists as opposed to fungi. So we've got our scrambled egg slime mold, or sometimes it's called dog vomit slime mold. You can definitely see why, right? And then down below our coral slime mold, okay, which again is going to be found on mostly hardwoods. Okay. All right. I wanted to talk briefly about some sort of promising possibilities when it comes to our decomposers and our detritivores and our scavengers. There's some cool research out there that's being done. You know, as humans, we've really altered the planet, as I'm sure you are all aware, and our waste is certainly problematic, right? What to do with it, right? How to get rid of it. And so some of our decomposers, detritivores, and scavengers, you know, show some promise in terms of helping us with our waste problems. So one thing I learned recently from a great book called Never Home Alone is that there is bacteria in the guts of camel crickets that can break down really toxic waste from the paper industry. So scientists are exploring how these bacteria that degrade lignin, which again is usually the job of fungi, so it's pretty fascinating that bacteria can do it, might be able to convert waste into biofuel. And again, bacteria can break down lignin much faster than fungi, so there's a lot of research being done to figure out how do we grow this bacteria, how do we put it to work, because it can do the job so much more quickly than fungi can, and it can do so in a much more reliable way. There's only a few species that do it, and some of those species are living inside the guts of camel crickets that are probably in your basement, right? There's so much about camel crickets that we don't know because they are sort of ubiquitous. And they're kind of all around us, and sometimes with things that are all around us, it becomes like a blind spot, right? We see it all the time. Researchers think, oh, someone else has probably researched that. I don't need to research it. So there's all this work being done with camel crickets, and so figuring out, well, what do they eat down there in the basement where there isn't a whole lot going on? And if you've got camel crickets in your basement, you know they can eat pretty much anything, and part of that is because of this bacteria that's in their guts. Countries in the Middle East, right, are looking into improved crop growth in very dry areas with the help of those mycorrhizal fungi that we talked about, right? Sort of on a similar note, right, research has shown that large-scale reforestation nurseries that inoculate trees with that fungi see improved seedling performance, so the greater growth and increased survivability because that mycorrhizal fungi is providing the nutrients, right, and in return getting some sugars from the tree, but not injuring or harming the tree in any way. Bacteria are regularly used to treat wastewater, so we've got our wastewater treatment plant, an aerial view of our very own wastewater treatment plant here in Arlington, which if you're curious, you can actually take a tour of. I learned that recently, maybe not right now during this time, but certainly when things open back up again, if that's something you're curious about, certainly worth exploring. So bacteria are used to sort of break down some of that sludge, but then that bacteria is left over, right, and that needs to be dealt with. So scientists and researchers are exploring how some of that leftover bacteria can be used to generate electricity, right? The bacteria liberate electrons as they're respiring while they're processing waste, and so there's a lot of potential there to turn that energy into something useful for people as opposed to just letting the bacteria sit there. Scientists are also exploring how some fungi and bacteria might help recycle batteries and other products with heavy metals. So some fungi produce organic acids that help to leach heavy metals out of whatever they're growing on, which makes the metals easier to isolate and then reuse or repurpose or store in a safe way. Some fungi also bind or absorb heavy metals, so sort of a different strategy. Instead of leaching those heavy metals out, they're binding them or absorbing them and taking them out of those used batteries. And as we start to sort of move to a future where we're moving away from gasoline and fossil fuels, and we're looking at batteries as an alternative, right? We've got to figure out what to do with those batteries when they're no longer useful. So fungi and some bacteria are sort of showing some promising things there in terms of how do we deal with the heavy metals and the toxins that still exist inside these batteries, even though we're done using them. Their useful life has come to an end. Okay, so there are so many possibilities out there. These are just a few. You know, if you're interested in this, I would encourage you to keep exploring it. I've just included like a very select little bit of what's out there, just to sort of give you a little taste of all the cool things that our decomposers can help us do. Okay. How to help on your own property if you've got your own yard or you have access to public space that you can sort of help care for. The best thing to do is let decomposition happen, right? Your leaves, your grass clippings, any stumps in the yard, let them stay. Allow snags or dead trees to stay if they don't pose a threat to your safety or any important structures on your property. Incorporate fallen logs and branches into your landscaping, right? Really helps to facilitate decomposition and let it happen where you live. I would encourage you to reduce or eliminate your use of pesticides and insecticides, right? So many of our detritivores could be negatively impacted by the use of those substances, as well as rodenticides, right? When we think about our scavengers, like our turkey vultures and our black vultures, if they are eating a rat that's been unfortunately poisoned by rodenticide, they are also going to have that poison accumulate in their bodies. So we want to sort of eliminate that spread of that rodenticide around our food web that we saw. So just not using it. There are other ways to get rid of rodents if they are pests on your property. I'd encourage you to plant native. That's always a good strategy, right? If you're going to be planting stuff in your yard, choose plants that are native to the area, that support insects that are native to the area. You'll have a much greater diversity of life in your yard as a result. Practicing leave no trace ethics when you're exploring. So if you do go out there, you are curious about fungi, you want to get close to those detritivores, you're rolling over logs, you're moving branches, just going to put things back where you found them. I always, when I roll over a log, roll that log over so I roll it towards me. So the part of the log that is exposed, the ground that's exposed, is away from me. So if there's any creatures under that log, they have the chance to sort of get away without coming right towards me. And then when I'm done, I roll that log gently back in place, right? So anything that has been disturbed has a chance to kind of come back and hang out where it was before. I will say too, if you're going to forage for mushrooms, if you have a property nearby or you've gotten permission from a landowner to forage for mushrooms, please do so responsibly. We want to make sure to leave enough fungi in the forest for other creatures. We want that fungi to be able to do its job. Certainly, I have seen folks collect a bunch of mushrooms and then find out what those mushrooms are, and they might not even be edible. So figuring out as best as you can, right? I understand mushroom identification can be tricky, but figuring out as best as you can in the field if that's a mushroom that's even worth foraging before you pick it and bring it home, right? That mushroom, again, is the reproductive part of the fungi. So if we want that fungi to spread, some of that reproductive part needs to stay. And we do want to be just aware that there are lots of animals that depend on fungi as a food source in the forest, so leaving some for other creatures as well. I'm going to come back to that because I did have some resources I wanted to share with you. I will go ahead and send out this slideshow after the program, so you'll have these links available in your email, but there are some great guides to fungi available online from the U.S. Forest Service, as well as the Howard County Bird Club. They've got some members who love fungi, and they've got a great little guide to the fungi of Howard County, which is not too far from Arlington, so there's a lot of overlap there. Some great online guides to some of our detritivores. So our land snails and slugs have a great page of their own, specific to the Mid-Atlantic. General bug and insect identification, I love bugguide.net. Works sort of like iNaturalist, where you can submit a photo I would say that it has a good number of professional entomologists on there, so they really can help you figure out what you found, as well as a whole assortment of books that I love that we've got at the Nature Center that are great for identification if that's what you're curious about. So mushrooms as well as insects, backyard bugs.